We will cover template binding, creating and nesting components, component communication, styling, looping over collections, and conditional rendering. This is going to be an exciting section, so without further ado, let's jump right in. So far, we have been using double curly braces or interpolation for string binding. This works great when you need to display text between HTML elements, like showing a title or description inside a paragraph or H1. But what about when we need to bind data to element properties or attributes? For example, the src of an image tag or href of an anchor tag, the disabled state of a button, etc. For these scenarios, interpolation won't cut it. Instead, we use the property binding with square brackets to bind values dynamically. If we scroll down, we can see that the existing models has some changes. I have already made those changes in the respective files. The recipe model now contains an image URL as an additional property. Note that the image URL mentioned in the example may not work, which is this one, the one with viaplaceholder.com. Instead of that, what I am using is something similar called placehold.co. The task is to add an image tag and use the property binding to dynamically display the image. We also need to add an alt attribute since this is an image, and in case the image doesn't load, the fallback alt attribute is great for accessibility compliances. This task is very easy and let's knock it off in a minute. Let's add an img tag, the image tag, and let's add the src, bind the src using the property binding to recipe.image URL. The square bracket basically says whatever this should be bound to src. So the image URL essentially gets bound dynamically to the src property, and similarly let's bind the alt attribute to the recipe's name. Let's do alt with the square brackets to recipe dot name. Make sure that you will have to use the invocation so that we invoke the signal to get the value out of it. Let's jump back to the web view and we can see that the image is already here. If we click the next recipe, it jumps to the caprese salad. If you click the previous recipe, we have the spaghetti carbonara. Let's jump back to the terminal and say done. Let the AI evaluate the code. And it says, as usual, excellent work. You have successfully added an image to your recipe display using property binding, making your application much more visually engaging. The alt attribute for accessibility is a great touch. The next concept is all about components. But wait, didn't we already cover this at the beginning? Yes, but now we are going to talk about the why and how to break your application into multiple components. As the application grows, stuffing all the logic into one single component becomes unmanageable. It goes against the very principle of component-based architecture, which is all about breaking down our UI into smaller, reusable, focused pieces. Think of it like building with Lego blocks. Each block has a specific purpose, and you combine them to create something larger. And to help us with that, we can rely on Angular CLI. CLI makes creating components incredibly easy. Instead of manually creating all the files one by one, we can generate a complete component with one single command. In the terminal, if we issue this command ng-gc and the name of the component, for example, hello world, where ng stands for Angular, g is for generate, and c is for component. So in short, this command basically says, hey Angular, please generate a component with the name of hello world. This will automatically create a new folder with the component name, generate all four files, the HTML, CSS, TypeScript and spec file, set up the @component decorator with the correct configuration and place it in the right location within the project structure. And this is not just about components. The CLI can generate pipes, services, directives, guards, and more with similar shortcuts. It's a massive time saver and ensures consistency across the project. If we issue this command, we can see that it has created the hello world.css, hello world.spec, hello world.ts, and hello world.html within the app folder. If we go back to the application and check, we can see that the hello world folder is here and the hello world ts is already wired up with all the things that we need to start building the component. The project exercise here is a refactoring task. And let me share my perspective on this from personal experience. Angular has put food on my table for the past 7 years, and refactoring is something that I have done day in, day out. It's inevitable as the application grows. Is it uncomfortable? Yes, at times. Especially when you are breaking apart the code that's already been working fine. But you know what's more uncomfortable? Sitting on a Friday evening until midnight trying to fix a production issue in a massive, tangled component that nobody wants to touch. Refactoring matters. Here is the bottom line. Get comfortable with refactoring now. Make it second nature. It's one of the most valuable skills you will develop as you move forward in your developer journey. To have a testable, readable, maintainable code base, refactoring is a must. The future you who takes a look at your own code and your teammates both will thank you equally if you do this one thing right. Here, we need to create a recipe list component and move all the recipe related logic into that component. After that, the app should just be a container. From a visual perspective in web view, nothing should change. But from a code perspective, everything related to recipe should now be a part of that component. Let's practice some CLI prompting too. Head back to the command line and issue this command, ng-gc recipe-list. This will scaffold a component folder in the application. We have recipe-list as a folder within which we have the CSS, HTML, spec, and TS files. Let's start the refactoring process. Let me put the recipe-list side by side. And to make app a container, let's move all the methods and signal properties from app component, leaving the title because this is specific to the app component. Let's move this to the recipe list. Essentially, these things needs to be taken out. Let's import these one by one. Signal, recipe model, mock recipes, and computed. Now that the recipe-list.ts doesn't have any issues, let's take the HTML piece from app.html. Apart from the title, let's pick all these HTML elements from app.html and move to recipe-list.html. And to complete the wire up, let's take the recipe list component and register the same within the imports array so that we can make use of the app-recipe-list within the app.component.html as a custom component. Now, if we go back to the web view, everything should remain the same, but we have refactored the same from the app component to the recipe list component. Is the functionality working fine? Yes, indeed. And to confirm with the Gemini CLI, let's go to the CLI and type done. So it went through the code base and it figured out that it looks like you are almost there, and for this exercise the app.html should only contain the app-recipe-list selector. Alright, so it doesn't need this h1 title. Let's save it and say done once again. Finally, you have done an excellent job with this refactoring. You have created a new component, moved all the relevant logic and template code into it, and cleaned up your app component. This is a crucial skill for building scalable Angular applications. That's it for this video. Moving to module 9 in the next video, where we discuss about component communication with signals. See you soon. Thank you and bye-bye.